Hi guys, so let's solve yung problems sa lecture 4. Okay. So, for the first problem we have this figure. Sabi, determine the normal force, shear, and bending moment at C. At point C of the beam. So, you have a 3 meter cantilever beam subject to a triangular load. Tapos yung point C is nasa gitna. Okay, so, ano yung una mong gagawin? First, you show yung reactions dun sa support. Okay, so we have 3. So, yung along X, along Y, and yung moment. Okay. Now, what is required of the problem is yung normal, shear, and moment at C. Okay, so, to solve, we sum moments about A. Okay, so pag nag-sum ka ng moment dito, magka-cancel si AX and AY. Hindi mo na sila kailangan i-solve. You'd be left with MA as your unknown. So, MA, sinet ko siya as counterclockwise in direction, so it's positive. MA, so minus your area of your triangle, so that's 1/2. Base na 3 times 1,200 Newton per meter. And then, times yung moment arm, which is 1/3 of yung haba ng load. So, 1/3 of 3. Okay. And then, equals 0. Solving for MA, MA is 1,800 Newton meter counterclockwise. Okay. And then, summing forces along X and along Y, you will get AY to be 1,800 newtons upward. And AX ay 0 kasi wala namang ibang X force, no? Force along your X-axis. Next, dahil meron na tayong values nitong tatlo, we can proceed to cutting the beam at point C. No? Pag kinat mo yan, you will be exposing the internal forces, which are shear at C, normal force at C, and the moment at C. Ayan. Tapos, pag kinat mo siya, yung triangular load, syempre, makakat din. No? So, aalamin mo ngayon, ano yung value nung load dito. Kasi, your load is decreasing from 1,200 hanggang mag-0 sa point B. Kaya lang, dito tayo sa gitna. Dahil uniform naman yung pag-decrease niya, ibig sabihin, since this point C is halfway nung beam, ibig sabihin, yung load mo dito is half din of 1,200. That's why we have here 600 newtons per meter na load. So, yung beam natin is subject sa 1,200 newton per meter. Pababa, yung paliit yung load hanggang mag 600 newton per meter siya, 1.5 meters from point A. Ayan. So, dito sa free body diagram na to, I also included yung values ng AY and moment at A. Now, we'll be using this figure to generate the next equations. So, it would be easy to sum moments about C para matanggal yung unknowns natin na NC and VC, and for us to be able to solve for the moment at C. Okay, so, summing moments about C, you will have 1,800. So, ito yon yung moment natin. It's counterclockwise in direction niya, so it's positive. And then, yung 1,800 Newton force, so negative siya, clockwise, ano? So, negative 1,800 times 1.5 meters. And then, plus, ang inad ko dyan is yung 600, itong rectangular load na 600. So, that's 600 times 1.5 times moment arm na half ng 1.5. Okay? And then, i-add mo din yung natitirang triangular load dito na maliit. Okay? maliit na triangle. So, that would be 1/2 base na 1.5 times height. So, ano yung height ng triangle natin na maliit? So, that's 1,200 minus 600. Okay? Tapos, times mo yung moment arm. Nasaan yung centroid ng triangle mo? It's here, di ba? So, that is 2/3 from point C. Kaya, 2/3 times 1.5. Okay? And then, don't forget yung MC natin dito. Okay, so, sinet natin, MC is counterclockwise in direction. So, plus MC equals 0. Solving, we get MC to be negative 225. Therefore, MC pala is clockwise. Okay, so, final answer, the moment at C is 225 Newton meters clockwise. Okay. And then, summing forces along Y, you'll have 1,800 minus VC minus 1/2 ito yung triangle. So, 1/2 base times yung height na 600. Okay, 1,200 minus 600. And then, minus yung ito naman, yung yung rectangular load na to. Ito. Okay. So, siya naman yung 600 times 1.5. And then, equals 0. Okay. So, solving, we get VC to be negative 450. So, baliktad pala yung direction ni VC. No? So, VC pala is 450 newtons upward. Alright? And then, summing forces along X, wala namang ibang X dyan, therefore, NC is 0. Okay, so, ito yung sagot. Next, we have another triangular load, pero this time, yung beam naman natin is simply supported. So, draw the shear and moment diagrams for the beam shown. Ayan. So, you have a 9-meter beam, naka-pin sa left, naka-roller sa right. And then, you have a uniformly increasing triangular load na 6 kN per meter. Okay, so, to write the given, you just redraw the figure and then draw the corresponding reactions. No? So, what is required is to create yung shear and moment diagrams. Now, for the solution, we some moments about A to find the value of BY. Okay, so that will be BY times 9, right? Minus area ng triangle 1/2 base na 9 times yung height na 6. And then times the moment arm na 2/3 ng 9. Okay. Solving, we have BY to be 18 kilonewtons. And then, summing forces along X, you get AX to be 0. Summing forces along Y, you'll solve AY to be 9 kilonewtons. Ayan. Next naman, guys, is we will generate equations for shear and moment. So, ito hindi to nagawa dun sa classroom. No? So, generating the equations. Now, how do we generate equations for shear and moment? You will cut your beam. So, for this, kinat ko yung beam and let's say the beam is X meters long. Upon cutting the beam, of course, ma-expose yung internal forces. Hindi ko na nilagay yung normal force kasi obviously yung normal force ay 0. Okay, so I only included yung shear and yung moment. Alright, so I copied the reaction dun sa left, which is 9 kilonewtons. Okay. And para naman dun sa load sa taas, syempre hindi siya 6, no? Pero alam natin na the overall length of the beam is 9 and the maximum load here is 6. So, ibig sabihin, yung load natin is 2/3 of our length. So if we have a length na x, then yung load dito would be 2/3 of x. Okay? So, ayan, meron na tayong panibagong free body diagram. Now, from this free body diagram, we will sum forces along y, and we'd be able to generate this equation. So, 9 minus v minus, ito, yung triangle. So, 1/2 base na x times height na 2/3 of x equals 0. Now, rearranging the equation, we'll have v equal to 9 minus x squared over 3. Okay, so this is our equation for shear. Next, let us sum moments at a distance x from A. So, dito naman tayo mag-sum ng moment para maalis natin yung v. Right? So, we have m. So, m is counterclockwise, so that's positive. M plus yung triangular load natin, so 1/2 base times height na 2/3 x times moment arm na 1/3 of x, and then minus itong 9 kN load dahil clockwise siya, so minus 9 times moment arm na x equals 0. Rearranging, simplifying the equation, we'll have m equal to 9x minus x cubed over 9. So, ito naman yung ating moment equation. Okay, so, para saan sila? So, we'll be able to use them later. To generate the shear and moment diagram, so let us redraw the beam. So, together with the reactions. And so, we have 9 sa left and 18 kN sa right. To proceed in drawing the shear diagram, so dahil sa 9 kN force, 9 kN na reaction, we have positive shear na 9, and then we subtract yung tawag dito, load na to, yung triangular load. So from 9 we subtract 1/2 times 9 times 6. Okay, so you'll get negative 18. And then from here, magkakaroon ka ng 18 kN upward reaction. So nag-zero na yung ating shear diagram. Okay, so this is our shear diagram. You have a degree of freedom of 2. And then the equation for shear is 9 minus x squared minus x squared over 3. And then, if you will notice, yung shear diagram natin, nag-zero somewhere here, diba? To get this distance, kung saan ba nag-zero yung shear, we will make use of our shear equation. Okay? So, setting v equal to 0, kasi we want to determine the distance x where shear became 0, where the shear became 0. Okay, so yung 9 minus x squared over 3 is set natin to be equal to 0, and then solving for x, we'll get x equal to 5.196 meters. So, anong ibig sabihin yan? Kapag yung shear diagram mo, nagkaroon ka ng point of zero shear, yun yung location ng maximum moment. Right? Point of zero shear is the location of your maximum moment. So, itong value na to, pwede natin yan magamit in order for us to solve, to know kung ano yung maximum moment. Kasi, di ba, meron tayong moment equation. So, m equals 9x minus x cubed over 9. Okay, so substituting x na 5.196 meters, masusolve natin yung maximum moment to be 31.177 kilonewton meter. Okay, so nag-substitute lang. Now, the degree of freedom of our moment diagram is 3. Okay, doon sa shear diagram natin naman is 2. Okay, so, ayan. Next, we have a cantilever beam. So, ganun ulit, draw the shear and moment diagram. This time, meron tayong concentrated load na 2 kN sa left, and then we have a uniformly distributed load from the middle of the beam hanggang sa right end. Okay. So, first, you solve for the reaction. So, hindi ko na sinulat yung yung reaction alang x kasi 0 naman yan. And hindi ko na rin pinakita yung yung step by step kung paano kunin si by and si mb. Okay? Practicing nyo na lang yan. So, there, you should get yung vertical reaction to be 5 kilonewtons and yung moment to be 11 kilonewton meter clockwise. Okay, hindi naman ito magiging counterclockwise kasi tingnan mo yung forces. Yung forces, pinupush nila yung beam pa counterclockwise. Siyempre, para maging in equilibrium, kailangan ika-counter ng moment. Kaya, kung mag-a-assume ka, babalik ka rin mo. So, dapat clockwise yung gawin mong assumption dito. Alright? Or kung hindi mo naman ginawang clockwise, mag-negative din naman yan pag nag-solve ka. So, there. Assuming that you now have the values for the moment at B and the vertical reaction at B. Okay, so, let's proceed to drawing the shear and the moment diagram. So, to draw the shear and the moment diagram, so from the left, we have a 2 kilonewton downward force, so -2. Tapos, from A to this point here, wala namang forces, external load, kung ano man. So, we have constant shear na -2 kilonewton. And then, from this point hanggang point B, nagkaroon ka na ng 1.5 kilonewton meter na distributed load. So, getting the area of this, that's just 1.5 times 2, so that is 3. So, -2 minus 3, you get -5. Okay. So, dito is, naka 0 degree ka dito. Meron na tayong DOF na 1. Okay. So, ayan. And then, pagdating dito sa point na to, nagkaroon tayo ng vertical reaction na 5 kilonewton. So, nag-close na yung ating shear diagram. So, bumalik na siya sa 0. Now, what about the moment diagram? So, to generate the moment diagram, we get the area of this one. So, that is -2 times 2. So, you get -4 kilonewton meters. So, kung ang degree of freedom natin dito is 0, dito we have 1. Okay, so, ayan, naging linear na siya. And then, from here, dahil negative pa rin yung shear, magsusubtract lang tayo ng value. Okay, so, getting the area of this, so, ano ba yan? 1/2. So, dahil trapezoidal, ito, base 1 plus base 2. So, 1/2 times 2 plus 5, so that's 7. And then times 2. Okay. So, ayan. You will, and then you add that to -4, you'll get -11 kilonewton meters. Okay. And then to draw the concavity or the curve, okay, so you have here negative decreasing na shear. So, ibig sabihin, yung moment diagram mo should be negative decreasing as well. Okay? So, negative increasing. Negative increasing. Okay, so, ayun. It should be curved in this manner. Okay? So, ayun, yun na siya. Next, we have this beam. Meron naman tayong overhang. Okay, so, kung simply supported, nasa dulo yung support. Ano? Pero dahil yung roller support natin is somewhere in between your beam, we call this an overhang beam. Okay, so, ayan. Yung overhang natin, meron tayong subject sa 4 kN per meter na force, na load. Okay, so, ganun din, draw the shear and moment diagram. So, again, you solve for the reactions. You should be able to get 2 kN reaction at A na pababa and 10 kN reaction at B na pataas. So, katulad nung kanina, we plot the shear. We draw the shear diagram. So, kung meron kang negative 2 pababa, so that's negative 2 na shear. And then, dahil wala namang other forces, so that would be constant, no? Same lang. And then, aakyat ka ng 10, so negative 2 plus 10, so you get 8 kilonewtons. And then, from your 8 here, you'll subtract yung effect nitong 4 kilonewton per meter na load. So, ano lang ba yung area nito? 4 times 2. So, 8 minus 8, you get 0. Okay, so, na-close na ulit yung ating shear diagram. Now, the degree of freedom from here to here, so that's 0. And then from here to here, that is 1. Now, to draw the moment diagram, you get the area of your negative shear here. So, area is negative 2 times 4, so this is negative 8 kilonewton meter. Okay, so your degree of freedom went from 0 to 1. So, linear na siya dyan. And then, yung negative 8 kilonewton meter mo, dahil dito, sa part na to, positive yung shear, we will be adding this area here. So, 1/2 base na 2 times height na 8. I-add mo yung sa negative 8, you'll get 0. Okay, and then your degree of freedom went from 1 to 2. Okay. So, ayan. That's all. Thank you.